is the first lecture, which is ventilation and air conditioning. So basically there's 4 topics in it, which is the ventilation system, the basic refrigeration cycle, air conditioning system, and the ducting design. So for the first part, we'll be covering the ventilation system and the basic refrigeration system. So ventilation system is basically your window. It's basically having wind blowing into your room and replacing the air inside the room with the outside air, either through either through mechanical or natural means. And basic refrigeration is basically your refrigerator. So you will learn how the cycle works, how it cools down your refrigerator. Air conditioning is air condition, and then ducting is the ducting design. So this is basically what you'll cover for ventilation. And this is your reference, which is How F and Geno. This is your building services book. And this is the notes here is gotten from here. So by the end of this course, you'll be able to apply the principle behind the design procedure of various building services technology. So after you have been through this ventilation, you'll be able to apply this principle. You'll understand what is the principle behind all this ventilation, how it works. So what is ventilation? So ventilation is basically a replacement of the air inside the room through the means of differences in pressure. So there's different criteria on how different criteria to fulfill on achieving this, and we will go more in depth in the next few slides. So as you can see here, this is the definition. So ventilation is a process of changing air in an enclosed space. It's also done with the changing of air by continuously withdrawing and replacing it with fresh air. So the source of air must be clean. So usually outside air is fresh and clean. So this is what ventilation is. So you want to have a window from a side, from one end to another end. This is to provide a continuous flow. There will be a other scenario which you will be able to see what is a good scenario and how will it determine how good your ventilation for a room is in the pictures in the slides. Okay, so why do we want ventilation? Okay, so during the time where technology is not so advanced, we do not have air conditioning. So that's why we want to have ventilation. Because there's no air conditioning previously, the way to replace the air is through the usage of natural ventilation or mechanical system. So what you have is you have a window and you have a fan. So the fan will be either to draw the air in or draw the air out of the room. So this way, this is called a mechanical ventilation. If it's a natural ventilation, then it's just an open window where the natural force, which is the wind, will blow into the room, and this in turn will cause all the air inside the room to be replaced with the new fresh air. So why do we need ventilation? This is to maintain air purity by means of having the correct oxygen content in the air. So in the outside environment, which is the atmosphere, we know that oxygen content is 21%. But in a room, if you do not regularly regulate the air inside, then as we breathe, the oxygen content in a room will decrease. That's why you want to have ventilation in a room. and also carbon dioxide content. So as we breathe, we exhale out carbon dioxide and moisture, which is the third one, which is control moisture. And then the fourth one is prevent heat concentration. So as we breathe, our breath exhale out carbon dioxide, moisture, and also heat. We ourselves, if we are not breathing, we are also emitting out excessive heat. And then the next one is remove excess heat. So everything is generating heat. If you have lighting, although it's providing light to us, but there's also a byproduct of it as it continuously being on, then it's also continuously emitting a small amount of heat. Same as with people and then machinery. So if you have a laptop and it's running, then the laptop will be generating heat. Then the next is dispersion, disperse the concentration of bacteria and dispose contamination. And the last one is provide a sense of freshness. So in a room, if it's not ventilated properly, then the air will turn stale. So if you have a place which is very damp, which is not shined by sunlight, means and it's also very cold or it's very hot, then mostly is if it's very hot, then it will be a very good place for bacteria or fungus to thrive and grow. And then if it's not regularly ventilated, dust will accumulate in the room and smell. The room will start to smell. So if you open the door to a storage room which do not have ventilation and they have only one door, you'll mostly find that the room is covered in dust or very bad smell. So ventilation, if ventilation is there, then all this smell and all this dust won't be so prominent. So this is why you want ventilation in a room, because you want to have a comfortable environment for us to be in it. If we do not require such comfort, if you're only gonna be in a room for a while, like a storage room, then we will not need such a good ventilation system to be in that room because we will not be doing our work in the room. That's why you will find that most of the storage room they are very dusty and they have a very moldy smell and mold will grow on the wall. Okay, so what is the requirement for ventilation? Why is it so important? So there's 3 points here. Ventilation requirement is a control of ventilation rate is influenced by various authority and codes practice and statutory requirement. So in Malaysia, ventilation requirements are laid out in parts 3 of UBBL. So this is UBBL is Uniform Building by Law. Okay, so this is if we are in the construction, UBBL is basically like the Holy Bible of the construction. So to see where the services are put, we'll always refer back to UBBL. This is the standard requirement for all the buildings. So you would they inside it will not be telling you how thick the concrete will be or how much steel to put in the concrete, but there's requirement to say that there's need this certain amount of window, this certain amount of lighting, this certain amount of ventilation, this safety feature. This is to make sure that all the building we build they are safe and comfortable. They are required to meet the standard that has been already established. So if you are building a building and if you do not refer to this requirement, then you will not be able to get the approval. So this is Malaysia's requirement law, which is UBBL 1984. So you can find this requirement online. I will be able to upload this to soon. Okay, so the next one is this is the requirement for different building. There's different requirement for air changes per hour. So you see that there's different room here, and there's air changes per hour here. So what it means by air changes per hour? So you see that assembly entrance have 3 to 6 air changes per hour, and a bathroom has 6 air changes per hour. So what it means by air changes per hour is, let's say for example, for the assembly, it requires 3 air changes per hour. This means that within an hour, all the air in the assembly room need to be changed 3 times. Means all the air inside this have to be replaced by fresh air up to 3 times per hour. So this is what it means by air changes per hour, and this is determined inside the UBBL. So it says that all these different building available here have different changes in the air change per hour. So if you are building a hospital, then you need to check how much air changes per hour is required. And with this air change per hour, you will be able to determine how big your ventilation or how big your window you need to put in that particular room or for that particular building. So each of them have different requirement. Then you have to refer back to the UBBL to determine how big the window you need to put. So are you able to achieve that sort of ventilation with natural wind? Or if you cannot achieve with the natural wind, then you will need to install the mechanical ventilation system in the building. So there is different type of ventilation system. So you can see here there's 4 types of ventilation system. Either you have mechanical or natural. So the first type is all natural, which is the supply and the exhaust. Both of them are natural. Means you do not have any fan in the inlet or the outlet here. The next is B, which is there's a mechanical supply and a natural exhaust. So you have a mechanical supply here. This mechanical supply works by drawing the air outside into the room. And then how ventilation works is through differences of pressure. When you are drawing air from the outside into the building, then you'll be creating a high pressure inside this room. Then because of the difference of pressure from inside here and outside here, as this fan is drawing the air into this room, then the pressure is increasing, and because the outside pressure is less than the inside, then this will in turn push out all the air into the atmosphere. So this is how the mechanical ventilation system works. When air is going in, the pressure inside will be high. Because the pressure inside is higher than the outside, then this will in turn force the air to be extracted out from the room. So likewise, this is the same case in C, which is natural and mechanical. So as the fan is pulling the air out of the room, this will cause a low pressure in this room. So as the air is, because of that, because inside this room the air pressure is low, then compared to the outside atmosphere, then the air will force itself into this room. So this is how ventilation works due to the difference of pressure. So depending on you putting a mechanical supply or a mechanical exhaust, there will be changes in either you are creating a high pressure in your room or a low pressure in your room to create ventilation. Okay, so the last one is a mechanical supply and exhaust. So in this case, you'll be continuously pumping in air here, and then you'll be pumping in out all the air into the atmosphere. So this will be costly because you, instead of having only one mechanical ventilation type, you'll be installing two mechanical ventilation. So this is a more detail on definition of the natural ventilation. So it's saying that natural ventilation is an economical means of providing air. Why it says so? Because natural ventilation uses the force of wind. Because you're only using the force of wind, you do not consume electricity. This is achieved by means of having an open window. So if your room have a lot of window, then you'll be able to change your air in your room easily. So the next one is it uses component integral with construction such as air brake and louvers or openable window. So what is air brake? Air brake is a brake but with a hollow on its body instead of a full volume brake. So let me open it quickly for you to show it to you. So oops, sorry, I'm wrong. Okay, so this is a air brake. So you will not find this air brake in a condo because it doesn't make sense to have an air brake in a condo. But where do you find it? You can find it if you have a very old landed building. So if you have a very old landed building, they actually installed it at the top of your building. Let's see if I can find an example here. Okay, so there's no example here. So this building will be, if it's installed in a residential building, you'll be installing it. It'll be quite an old building, 30 to 40 years ago. But usually this air brake you'll be able to find it at the government building or at the public toilet. Okay, so as you can see here, although it's not very clear, you can see that the top of this building, this is a TMB building, there's this air brake. So this function is to provide the changes of air in this building. So air can enter from any location, and they will be able to escape from this air brake. So why do we want to install our opening on top? This is because hot air rises. So we want to use it to serve additional function. Instead of installing at bottom, we want to install it at the top so that as the hot air rises, we will be able to replace the cool air outside by expelling out all this hot air and make sure the room is cool properly. Okay, so this is air brake. So what about louvers? So if louvers is a slanted window which have different slab on it. So show it to you. So if you study in government school, there's a louvers window which is something like this. So in school, you can either make it a permanent or a flexible joint. So you can either open or close this window. So the function of this is the same, is to provide ventilation, but you do not want the wind to go into your building. So the function is only to allow changes of air, but not drain or water into your building. So if this is the function of it, that's why the design is this way. So this is to prevent water to enter your room. Okay, the next one is openable window. So basically you have a window, a glass panel window that you can open, or you can have a louvers. Either that or you can have an air brake. So one of the problem with air brake is you'll only be installing it at a landed building. But if you have an air brake, you will not be able to install a aircon in your room, because if you have a hole in your room, you will not be able to properly cool down your whole room. Okay, so next one. Natural ventilation operate depends on one of the following. So the most important thing is wind. Natural ventilation works by having wind creating a positive pressure on the windward side of the building and flow in and out through opening like window. Either by stack effect. So what is stack effect? Stack effect is created by differences in temperature between the air inside and the air outside. So the warmer and less dense the air inside is replaced by the cooler dense air from the outside. So if you can see here, the main point is less dense. This is the difference in pressure. So as the air inside the room gets warm, then it will go up. Then as it go up, you'll be able to replace it with a cooler and denser air. So this is what it means by stack effect. So natural ventilation works with a combination of wind and this stack effect. So if you can see here, there's 4 cases which is 1, 2, and 3, and 4. So one provide a very good cross ventilation because you have an opening on the next on the side, the left and right side. This way, air will be able to go through the room and just change it. There's no disruption in the flow of the wind. But if you make the window at 2, like in 2 and 3, it will still be good, but only at 2. You want to avoid the case 3 and 4 because you're only having opening at this location at only one side. So one of the problem you will have if you have only opening at one side is if the air pressure inside this room and outside is the same, then even though if you're having the wind blowing into your window, you will not be having any air exchanges in your room. That is because your room have a very high pressure and the wind is not able to go into your room if you only have same opening facing the wind. So you do not want to have this sort of design, this is considered a very poor design. Number three is fair, but there's a high chance of it be going to poor if you have things blocking the wind. So usually if you're having a window, you want to put it at the opposite side, or you want to put it at the side by side, or on the different sides. Okay, so this is a diagram on the natural ventilation by wind, how the wind flows. So it's created using differences of pressure. So they have a positive pressure, means the wind are pushing into this building, and then because this building is having a higher pressure and there's opening at the other side, then this will be able to easily create a suction. This is a suction zone, and air will be extracted out from this room. So you'll be able to change the air inside this room. So this is a ventilation by stack effect. So as warm air is being created in this room, you know by science that warm air is always going up. So you have a roof extract ventilator, or you have a chimney, and then because air is going up and going up and out of this room, then you'll create a low pressure in this room. And because there's a low pressure compared to the outside pressure, then the fresh air which have a higher pressure will push itself into this room. So this is the stack effect for natural ventilation. So although natural ventilation is good, there's disadvantage to it. So if you do not have wind, then that is a problem with natural ventilation. But if you have a area which is always windy, then natural ventilation is good because wind is cheap. You do not need to install any mechanical fan. You just make an opening for a window and you have a natural ventilation. So if there's no wind, then you will not be able to change your air inside the room. So that's the only disadvantage to natural ventilation. Okay, what about mechanical ventilation? So mechanical ventilation works through the usage of electrically operated fan. So one good thing about mechanical ventilation as opposed to natural ventilation is that with the usage of this electric fan, you'll be able to provide positive ventilation at all times. And you can also install a filtration system. So you want to install a filtration system. This is to filter out the dusty air in the atmosphere. So although the outside air is fresh, there will be all this pollen, dust, and everything flying around in the air. So if you have a filtration system installed, then you'll be able to actually filter out all this flower pollen and dust and you only get the fresh air into the room. So there are generally a few types of mechanical ventilation system. So you can either have a natural inlet and a mechanical extract, or a mechanical inlet and a natural extract, or a mechanical inlet and extract for both. So as I previously explained to you guys, if you have a mechanical extract, you are basically creating a low pressure in your room. But if you're having a mechanical inlet, you are actually pushing the air from the outside into the room, creating a high pressure in the room. But if you have a mechanical inlet and extract. So this is basically to continuously just change the air in the room as per requirement. Okay. So inside the more detailed explanation, it will say the explanation also provide you differences area where this sort of system is being used. So for natural inlet and mechanical extract, so the common place to use this is at the kitchen, workshop, laboratory, internal bathroom, and assembly hall. But for mechanical inlet and natural extract, so this will mostly be used in office and certain type of factory. So this is a example. So you have a mechanical extractor, which is a fan located outside here, and you have a natural inlet, which is here, 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 or at the canopy here. So this can basically be a area for your kitchen. If you are cooking, then as you cook, the air will be filled with the smell of the cooking. So this will be quite unpleasant to the person who is not doing the work in the room, or if this is just a condo. So you want to expel all this air as to not let it linger in the room. You just on the fan and the fan will extract all this air and the smell out of this room. And then because there's a less air in this room, a low pressure in this room, the atmosphere itself will force the new air into the room. So the same for the next bottom figure diagram. And this is also new additional figure to show you how it works. So what are the advantage of mechanical ventilation? So it's able to provide ventilation at all times irrespective of outside condition. So as opposed to natural ventilation, we do not need to depend on the wind. Mechanical ventilation works by using the fan to draw in or draw out the air out of the room. So you'll be able to ventilate any space deep within a building. Let's say you have a very big building that span for 700-800 meter, maybe like a museum. So you need to install mechanical ventilation because natural ventilation will not be able to regulate the air inside the room because the building is so big and you have so many partitions. The natural force of the wind will not be able to change all the air inside that building. But one of the problem with mechanical ventilation is you need to invest a certain amount of budget because all this machinery and all this ducting costs money. And as you own it, you require yearly maintenance and also electricity costs. And the next disadvantage of the mechanical ventilation is that you need space for services. For these services, you need to provide the space to install your fan. You need to provide the space for all your ducting to carry the air from the room out. Because if you have a fan and you do not have a body or medium to carry all this air from a room to the outside of the atmosphere or outdoor, then this is not considered a mechanical ventilation. So these are in mechanical ventilation, there is 5 basic components. So the first is the fan, which is used to move the air. The second is the filter. So you want to put it at the point of entry either you're using natural or mechanical ventilation, your filter will only be at the point of entry, because you are to use it to remove any contamination, odor or particles. So there's no point to install it at the outlet, because you want to expel the air, not to trap the odor in the room. So filter is only installed at the entry of the ventilation. And the next one is ducting. So this ducting is the body, is the medium to transfer the air in between building. So the ducting can go for very long. So it will go from building to building, connecting either at one end at the inlet, which is the done using natural, and then at the end of the extractor, which is the fan. So if you can see here, this is actually the ducting. All of these are ducting. From the natural inlet here to the outlet here. So this is all the ducting. So if you have a filter, you want to install the filter at the air inlet here. If you have any inlet, that will be where you put your filter. But ducting is all this body that will carry all the air out, which is connected to the fan, out of the room. Okay, so for this is fire damper. So fire damper is installed to prevent fire burn through the wall opening by ductwork. So with ductwork, you know that there's your ductwork will be going through different building. So the fire damper will be installed at the wall of the room. They will be installed parallel to the wall opening, so that if a fire occur in the room, the fire will not spread into another room by means of the ductwork. So that's why you want to install a fire damper at the wall opening. So the wall opening is the difference between room 1 and room 2. You have a ductwork that run through a lot of room. So the fire damper will be there at the location where the ductwork is going through different room. So if a fire occur, that is a function of a fire damper. So that if you have a very good fire rating room where you require 5 hours to burn through the fire prevention system they have installed in it. But if you do not have this fire damper, then your 5 hours fire prevention system will fail, because the fire will spread through the ductwork. So that's why if you have a mechanical ventilation, it's very important to install a fire damper at the wall opening of the ductwork. So the last is the diffuser. So this is just a air distribution outlet. It can be in any shape, which is circular, square or rectangle. So this is the diagram to show you how the mechanical ventilation is. This is the fan, and then this is the ductwork of the mechanical ventilation system. Okay, so this is the filter. And this is the diffuser. So that's about it for the ventilation system. So ventilation system is basically either natural or mechanical. It uses the difference of air pressure. Sorry, not air pressure. It uses the difference of pressure. So there's a few things to remember for ventilation. It can be done naturally or mechanically. And then the basic means of how ventilation works is through the differences of pressure. Either you're creating a high pressure or a low pressure in the room. And then this will in terms cause the changes of air in the room. And then the next is the five component of ventilation: the fan, the filter, the ductwork, the fire damper, and the diffuser. So this is the few things that you need to remember for ventilation. Okay, so the next is basic refrigeration cycle. So this is basically what you have in your refrigerator. So this is a diagram to show how the refrigerator works by cooling down the air and making sure your refrigerator is cooled down. So basic refrigeration cycle. So most people think that air conditioner lowers the temperature in their home simply by pumping cool air in. What really happens is the heat from the warm air is being removed and cycled back in as cooler air. So this cycle is known as refrigerant cycle and continue until your thermostat reaches the desired temperature. So basic refrigeration cycle. This is the same like your air conditioning or your refrigerator or your air or your car air cooled conditioner. So they are all basically working in the same way. There are four components to this air conditioning system, which is compressor, condenser, the metering device is the expansion valve, and the evaporator. So these are the four main components in the refrigerant cycle. So this basic vapor compression cycle basically shows you a very good idea on how refrigerant cycle works. So you have a gas. You have a gas. So basically, a refrigerant use a gas in this cycle. So there's two distinct area, which is a high pressure and a low pressure. So there is four component here that is discussed in previously. This is a component. This is a major component, which is a compressor, condenser, expansion valve, and the evaporator. So the compressor is important because it causes the gas, which is at a low pressure. It will make the gas into high pressure. So when the gas is high pressure, it will move to this condenser. So this condenser is where the refrigerant release the heat in it. So refrigerant is the gas inside this system. There's a unique sense to it. I will explain this in detail, but refrigerant is the gas in this refrigerator cycle. So there's four components in this. So the compressor will compress this refrigerant from low pressure to high pressure. This is the function. This is the first component function. So it compresses the gas and it will move to condenser. Then at this condenser, heat will be released. And then once the heat is released, it will move to this expansion valve. So the function of this expansion valve is to reduce the pressure. So once the pressure is reduced, it will become a liquid and gas sort, and then it will go to the evaporator. So at this evaporator, the heat would be absorbed into this refrigerant, and then it will move to this compressor. So this is a cycle. So you often find that if you open your refrigerator door, this evaporator will be located at that location, and these three things will be located behind the machine. So condenser is where all the heat will be released, so it will be very hot, and evaporator is where all this cool air is being blown out. And these two, the function is to reduce and increase the pressure of this gas. So when the compressor increase the pressure, the gas will change into some sort of like a liquid state. So once all the heat is released at this condenser location, then it will move to this expansion valve. So this will cause the gas, the liquid, the refrigerant liquid, to expand to become some sort of like a liquid gas. So for the function, the basically you can split it into two things. So condenser is to release the heat, evaporator is to absorb the heat. Compressor is to increase the pressure of the gas, and expansion valve is to reduce the pressure of the gas. So to this is a very good figure to understand what the basic vapor compression cycle is. Okay, so this is an additional picture. So we are going through A, B, C, D, which is the compression, condensation, expansion, and evaporator. So they are going through a cycle of being a liquid and a gas. Okay, so this is an explanation on the refrigerant. So refrigerant is a substance used in the air conditioning to absorb and transfer the heat, thus causing a cooling effect. So refrigerant is a type of gas that is specially formulated. So you will not be able to find you will find that not every gas behave in a way that is suitable for refrigerant. So to qualify as a refrigerant, you need to possess this following characteristic. You have to be low boiling point, high latent heat of vaporization. So what it means by latent heat means is able to easily exchange the heat, means is able to get hot and cold very quickly. And then easy liquefaction by compression means is able to become liquid when you put pressure on it. So it's stable and non-corrosive because you will be using it for the public. So in case someone break the pipe for the refrigerator for this cycle, in case they break the pipe, it is stable and you do not kill the consumer, and also environment friendly. So these two are linked together. So you do not want to make something that make something for the public, for everyone, that in case someone accidentally break the pipe, that you kill the person. So if you kill the person, then there will be a lot of lawsuit coming after you. So refrigerant is a specially formulated gas to be used in this refrigerant cycle. And this CFC is a good have these good properties, means they tick for 1, 2, 3, 4, but they fail for the environment because this harms the ozone layer. So okay, on to the next one. So there is different refrigerant, which is different gas, which is they can be R22, HCFC 22, so or either the HCFC. There's also the freon, so this is already phased out. Hydrocarbon, HC, propane, butane, carbon dioxide, ammonia, or the hydrofluorocarbon. So you know that refrigerant cycle is basically, to summarize, refrigerant cycle is basically this diagram. So you need to remember this diagram. Like the ventilation, it deals with high pressure and low pressure. Remember that not every gas is suitable to be used in this refrigerant cycle, because you want to be able to easily compress the air, compress this refrigerant gas from low pressure to high pressure. So when you compress from low pressure to high pressure, you'll be compressing it into something like a liquid, so that when it's going through this condenser, because it has a very high latent heat, you'll be able to easily release all this heat out into the atmosphere. And then when you move to the expansion valve, when you reduce the pressure of this liquid, you'll be able to get some sort of like a liquid gas. And then you move it to the evaporator. So at this location, the refrigerant will try to absorb as much heat as possible at the location where you want the area to be cool. So that this is a low cooling point gas. And then once it goes through this evaporator, you go to the compressor. So this is a cycle. You go from high pressure to release the gas, to release the heat, to the low pressure, which is you want to absorb the heat. So not every gas behave the same way. You have a specific gas which have all these properties that will qualify the gas as a good refrigerant. So you can have all of these, but most of the time, the gas that we have is not very safe for the environment. Although it's not toxic and corrosive and stable, but to hit the environment safety, we will have to do a lot of research to make a gas that is allowed to meet the public demand. So this is a different gases that you can find in your refrigerator, or either your air conditioning system, or your car air conditioning system. So any conditioning system that is used to cool down the air or blow out cool air, all of them have this. All of them either have this or another type of gas in the system. They are used to cool down the air. Okay, so the next is the air conditioning. So I'll stop here for part 1.